On June 29, 2023, a paper was published in the physics journal that mentioned a special kind of waves spreading throughout the universe. These waves are such that our own Milky Way galaxy and every galaxy in the universe are floating like ships in the ocean. Even as you are watching this video, these mysterious waves are passing through you and me all the time and are disturbing our atoms. To detect these waves, scientists had to take the help of neutron stars present in the universe. But according to scientists, we should be happy rather than afraid of the existence of these waves, because now, through these mysterious waves, we can uncover some mysteries of the universe that perhaps were not possible to solve before, such as the Big Bang explosion, the internal atomic structure of planets and stars far away from Earth, and even the internal structure of black holes. Now, the question arises, what exactly are these mysterious waves in the universe and how are they generated? So, hello guys, you are watching Brain Bargain, and let's start another new episode. In 1916, when Albert Einstein published the general theory of relativity, he mentioned a special kind of waves. These were not waves generated by the flow of water in seas or rivers, but waves generated in the fabric of space-time of our entire universe, which could travel at the speed of light and were generated from the collision of massive objects like black holes and neutron stars. However, most scientists at the time did not believe in the existence of such gravitational waves because gravitational waves had never been observed until then. In 1974, when two astronomers, Taylor and Hulse, were observing a binary pulsar system located 21,000 light-years away from Earth using the Arecibo American Radio Observatory, strange vibrations were coming towards Earth. After a few days of research, it was realized that these were gravitational waves generated in the space-time fabric by these binary stars, as predicted by Albert Einstein. Hulse and Taylor were awarded the Nobel Prize for their discovery in 1993, but our knowledge about gravitational waves was still quite limited. According to Einstein, such gravitational waves float in our universe all the time, helping us understand the universe. However, to study them better, a special kind of laboratory was needed, and in 1994, America and several countries around the world started working on building such a laboratory. This Earth-based laboratory, capable of detecting gravitational waves floating in the universe, was named LIGO, or the Laser Interferometer Gravitational Wave Observatory. Talking about its structure, LIGO mainly consists of two long L-shaped steel tubes, each 4 kilometers long, with highly sensitive mirrors at the ends. A laser is directed through these tubes, redirected by the mirrors at both ends, and the laser meets at a point. When a gravitational wave passes through the Earth, it slightly distorts the point where the laser is focused, and this distortion is detected with the help of highly sensitive detectors installed in LIGO. According to scientists, LIGO's detectors can detect changes as small as the atomic level. Although LIGO began observations in 2001, its most significant success came 14 years later, and almost 100 years after Einstein's prediction in 2015. The gravitational waves that existed only in theory and were predicted by Einstein were now physically detected due to the LIGO facility. These gravitational waves were generated from the merger of two massive black holes located 1.3 billion light-years away. Thus, the detection of gravitational waves by LIGO became one of the greatest achievements in human history because, after light, gravitational waves are the only thing that can pass through every celestial object. Studying gravitational waves provides a new way to understand the universe and the internal structure of distant planets and stars. However, the problem with the LIGO facility is that it can easily detect highly energetic gravitational waves of small wavelengths. Still, when it comes to weak and large wavelength gravitational waves, especially those with wavelengths spanning thousands of light-years, the LIGO facility's detectors fail entirely. But there is a second way, which can help detect even the smallest gravitational waves floating in the ocean of the universe. This method has provided us with some strange insights into gravitational waves, connecting them from the beginning of the Big Bang to the rapid inflation process and cosmic string theory. In the 1960s, researchers observed that pulsars in the universe, especially millisecond pulsars which spin hundreds and even thousands of times per second, have a spin cycle more accurate than an atomic clock. This means that by measuring the distance and time of the light coming towards Earth after each spin, we can study the small changes in this fixed distance and time to easily detect large wavelength gravitational waves floating in the universe. Gravitational waves stretch space-time, causing the distance between these pulsars and Earth to increase and decrease by very small amounts, which slightly alters the timing of the light coming from them. By calculating these changes, we can detect even the weakest gravitational waves. Let's understand it with an example. When ships float in the sea, they have navigation lights that help determine the moving direction of another ship. If you see the navigation light of another ship from your ship and notice that the light is moving up and down rapidly, it means that the ship is caught in a large wave or storm, and other sailors avoid heading in that direction. Similarly, when the light from pulsar stars reaches Earth and deviates, it indicates that gravitational waves are causing these deviations by moving heavy celestial objects like pulsars and changing their direction. The first survey to detect gravitational waves using pulsars was started in 2016 under the name Pulsar Timing Array. However, research on this detection method primarily began in the last decade, with the world's best radio observatories detecting light from different pulsars according to their location. The first was the Australian Parkes Pulsar Timing Array, which started collecting data in 2005. Following this, the European Pulsar Timing Array, North American, Indian, and Chinese pulsar arrays, as well as the South African Observatory, joined this scientific initiative and began collecting data from different pulsars. In short, some of the world's largest radio telescopes continuously observed these pulsar stars, calculating the timing deviations of light from these pulsars over many years. Finally, after years, a breakthrough was achieved in 2023. By combining 15 years of data from the North American and European pulsar timing arrays, it was discovered that gravitational waves continuously vibrate in the universe and float through our universe, passing through every object in their path, causing slight deviations in spacetime and even the atoms of these objects. This data was later confirmed by the Indian and Chinese pulsar timing arrays. During this entire research, scientists discovered another interesting fact about these gravitational waves. Large wavelength gravitational waves are not only produced by the collision of massive objects, but are also developing continuously and are present all around us. Recently, data from the European Pulsar Timing Array was compared with the Indian Pulsar Timing Array, yielding the same results. These results, published in 2024, pointed out that gravitational waves are floating everywhere in the universe all the time, and their magnitude is so low that we cannot feel them. Many scientists think we now have something that allows us to study the universe at a deeper level because these gravitational waves pass through every object in the universe at the atomic level. If we can detect these gravitational waves better, we can learn a lot about supernovae, cosmic dark energy, other celestial objects like planets, stars, and even galaxy structures. We might even gain insights into the internal structure of black holes, which remain a mystery to us humans. Additionally, we can map various parts of the universe through these gravitational waves. Since many gravitational waves have been floating around since the Big Bang, we can learn a lot about the Big Bang as well. But the question is, how are these gravitational waves being generated continuously in the universe? And what is their source? After detecting them, we know that they are present and constantly floating all around the universe. However, we still don't have the answer to how these very large wavelength, weak gravitational waves are being generated. Most gravitational waves are generated by the collisions of massive neutron stars and black holes, as we saw during the black hole collisions in 2015. But the continuous production of these waves at regular intervals with such low amplitude and their constant spread across the universe has led to various theories among scientists trying to explain their existence. Some scientists believe that the generation of these gravitational waves is due to the vibrations of cosmic strings in the universe. Others link them to the Big Bang, suggesting that these waves formed during the rapid expansion of the universe, known as inflation, right after the Big Bang. When the universe expanded from an atomic level to a cosmic level, these gravitational waves might have formed and still exist today as echoes of the Big Bang and the inflation process. Additionally, some scientists connect their formation to dark matter and mysterious neutrinos present in the universe. But to summarize, we currently don't have enough data to pinpoint the exact source of these gravitational waves. However, research is ongoing, and within a few years, it will become clearer what the real source of these gravitational waves is. You'll get updates on this channel, so make sure to subscribe to Brain Bargain. I hope you found some new information from this video. If you did, Please like this video and share it with your friends.